Now, Pauli's exclusion principle is another postulate of quantum mechanics, okay, that says that no more than 2 electrons, okay, can be assigned to an orbital. So if you want to describe electrons in an atom at any given instant, no more than 2 electrons can be in the same orbital, can be described by the same orbital function. It's like saying no maximum occupancy for a bedroom is 2. If you think of orbitals as bedrooms for electrons, then no more than 2 people to a bedroom. Okay? Now, if you have 2 electrons in an orbital, they must have opposite spins. Okay? So that means it's like saying if there's the limit of 2 people to a bedroom, if one is male, the other one must be female. That's just one way you can try to remember it. Okay? Good memory aid. And another way of saying Pauli's exclusion principle really says is to say that you cannot have this 2 electrons having the same set of 4 quantum numbers. So the 2 electrons can have the same N, L, and M. That would be the same orbital. Okay? Since you can put no more than 2 electrons to an orbital, one of those electrons must have, if they have 2 electrons with in the same orbital, they have the same N, L, and M, one of those electrons must be spin up, so m sub s plus 1/2, and the other electron must have opposite spin corresponding to a quantum number of m sub s equals -1/2. That's Pauli's exclusion principle. Let's look at this question. How many ways can the magnetism generated by the orbital motion, okay, of an electron in a 3p orbital be oriented? Then that means that's another way of asking how many possible m quantum numbers can you have for a p orbital. Well, for p orbital, L is 1, right? P orbitals always come in sets of 3. M can be +1, 0, or -1. So there are 3 ways. One's going to be oriented that way. It can be precessing about the z-axis like that, in that cone of uncertainty. The other one could be downward. Okay, this is m equals +1, m equals -1. Okay, and it could be on the xy plane itself, is m equals 0. So 3 ways. The magnetism generated by the orbital motion of an electron in a p orbital be oriented. How many ways can the intrinsic magnetism of an electron in a 4d orbital be oriented? Intrinsic magnetism, 2 ways, spin up or spin down. Okay. How many electrons can be assigned to a 4p subshell? In other words, how many electrons can we assign to n equals 4, L equals 1? We talked about this earlier, didn't we? Okay, so m can be 1, 0, or -1, right? And so m sub s can be +1/2 or -1/2. So 4, 1, 1. And you can have 4, 1, 0, +1/2. 4, 1, 0, -1/2. Okay, and then you can have 4, 1, -1, +1/2, and 4, 1, -1, -1/2. 6 possible sets of quantum numbers. That means you can assign 6 electrons to a 4p subshell. Let's take a look at this question. How many electrons can be assigned to a 4p orbital? Any orbital can have as much as 2 electrons. So the answer is 2. Okay? One of those 2 electrons must be spin up. The other one must be spin down. How many electrons can be assigned to the 3rd shell? N equals 3. What are the possible L values? You can have 3s, right? So L equals 0. Or 3p, L equals 1, or 3d, L equals 2. Okay. And your m can be, so this is all 3, right? M can be 0. If L is 1, your m can be +1, 0, or -1, right? that would be your 3p orbitals, right? So this is your 3s, 3p, and your 3d orbitals can be L equals 2, M equals plus 2, plus 1, 0, -1, -2. So how many orbitals do you have? 1 plus 3 plus 5. That's 9 orbitals. How many electrons can you assign to 9 orbitals? 2 electrons per orbital, right? So 18 electrons. 18 electrons, so most number of electrons you can assign to the third shell. And the reason for that is your m sub s can be plus 1/2 or -1/2. So you can have 18 possible sets of quantum number to describe electrons in the third shell.